Charles Steinmetz and Oliver Heaviside contributed the theoretical basis of alternating current engineering. The spread in the use of AC set off in the United States what has been called the War of the Currents between a George Westinghouse-backed AC system and a Thomas Edison-backed DC power system, with AC being adopted as the overall standard. During the development of radio, many scientists and inventors contributed to radio technology and electronics. The mathematical work of James Clerk Maxwell during the 1850s had shown the relationship of different forms of electromagnetic radiation, including the possibility of invisible airborne waves, later called radio waves, in his classic physics experiments of 1888. Heinrich Hertz proved Maxwell's theory by transmitting radio waves with a spark gap transmitter and detected them by using simple electrical devices. Other physicists experimented with these new waves and, in the process, developed devices for transmitting and detecting them. In 1895, Guglielmo Marconi began work on a way to adopt the known methods of transmitting and detecting these Hertzian waves into a purpose-built commercial wireless telegraphic system. Early on, he sent wireless signals over a distance of 1.5 miles. In December 1901, he sent wireless waves that are not affected by the curvature of the Earth. Marconi later transmitted the wireless signals across the Atlantic between Poldhu, Cornwall, and St. John's, Newfoundland, a distance of 2,100 miles, almost 3,400 kilometers. Electrical engineering has many subdisciplines, the most common of which are listed below. Although there are electrical engineers who focus exclusively on one of these subdisciplines, many deal with a combination of them. Sometimes, certain fields such as electronic engineering and computer engineering are considered separate disciplines in their own right. Electronic engineering involves the design and testing of electronic circuits that use the properties of components such as resistors, capacitors, inductors, diodes, and transistors to achieve a particular functionality. The tuned circuit, which allows the user of a radio to filter out all but a single station, is just one example of such a circuit. Another example to research is a pneumatic signal conditioner. Prior to the Second World War, the subject was commonly known as radio engineering and basically was restricted to aspects of communications and radar, commercial radio, and early television. Later, in post-war years, as consumer devices began to be developed, the field grew to include modern television, audio systems, computers, and microprocessors. In the mid to late 1950s, the term radio engineering gradually gave way to the name electronic engineering. Before the invention of the integrated circuit in 1959, electronic circuits were constructed from discrete components that could be manipulated by humans. These discrete circuits consumed much space and power and are limited in speed, although they are still common in some applications. By contrast, integrated circuits pack a large number, often millions, of tiny electrical components, mainly transistors, into a small chip around the size of a coin. This allowed for the powerful computers and other electronic devices we see today. Microelectronics engineering deals with the design and microfabrication of very small electronic circuit components for use in an integrated circuit or sometimes for use on their own as a general electronic component. The most common microelectronic components are semiconductor transistors, although all main electronic components like resistors, capacitors, etc. can be created at a microscopic level. Nanoelectronics is the further scaling of devices down to nanometer levels. Modern devices are already in the nanometer regime, with below 100 nanometer processing having been standard since around 2002. Microelectronic components are created by chemically fabricating wafers of semiconductors such as silicon at higher frequencies, compound semiconductors like gallium, arsenide, and indium phosphide to obtain the desired transport of electronic charge and control of current. The field of microelectronics involves a significant amount of chemistry and material science and requires the electronic engineer working in the field to have a very good working knowledge of the effects of quantum mechanics.